Now here we are going to reduce, but we've got to perform those indicated operations. So you're going to see some multiplication and division. Remember, when you multiply, that's easy. When you divide, you've got to take the reciprocal. So here you have some options. You can divide along the way, like 8 and 12. They're both divisible by 4. 5 goes into 10 2 times. Now here you have some choices with all those x's. I'm going to kind of clean it up first. So 2 times 2 is 4. And then x cubed times x cubed, keep the base, add the exponents. Then that's a 1 times 3, x squared, x to the 4th, keep the base, add the exponents. Now I'm going to reduce even more. Those divide out and I just get 4/3. Again, you could reduce the x's along the way. Sometimes they kind of get a little lost. So number 65, that's 8x squared over 5y times the reciprocal of what we're dividing by. So I'm going to reduce. 5 goes into 10 twice. 8 and 14 are both divisible by 2. And then I'm going to divide here and here. So that's going to leave me y to the 5th. And I'm going to divide here and here. And that's going to leave me y squared. If you do this cancel out method as you go along, you see how it can get very messy. I'm using different colors, so hopefully I won't lose everything. I've got a 4, a 2, and a y to the 5th, and then I've got that on the bottom. So 4 times 2 is 8, y to the 5th, and a 7x squared. Just double check. Can you divide any more or reduce? No. Can I just start canceling stuff out? No, I have to factor. Let's back up and compare. Why do I need a factor on 66, but I did not need to factor on 64 and 65? Because these were monomials, meaning a single term. Don't need to factor. These are on 66 and forward, those are binomials and trinomials, and you can only reduce common factors. So factoring that with a GCF, factoring that, it needs a 2, and then that can factor more times, now I have to put this on the bottom, take out that GCF, I have to put this on the top. So let's see, I need 3, 6 is either 2 and 3 or 6 and 1. I need to put the 2 here, the 3 here, check my signs. I think that'll work. Now do I have any common factors? Well, 2 into 2, x and the x, 3x minus 2 and 3x minus 2, x plus 3 and x plus 3. Wow, a lot of that divides out. That's your final answer. Factor the difference of two squares. Then let's see, 2 and 1. I've got to put this on the top. I've got to put that on the bottom. I'm just going to take a minute, check all my signs. I think that's okay. I can reduce. Those go away. Those go away. Those go away. And the only thing I have left is the x plus 4 over x minus 1. 68. Okay, I get to factor this. Plus 5 and minus 3. Ooh, got that 2. So I need a 2x, 45. 9 times 5. Let's see if we can make that work. Both of them negative. Does that give me a negative 19 in the middle? Yes, it does. So again, this goes upstairs, GCF. This goes downstairs, minus 3 and minus 3. Again, just checking on my signs, checking that I factored right, go over it. Then start reducing common factors on top and bottom, on top and bottom. Anything else? I think that's it. So I have 6 times x plus 5 on top, 2x minus 9, and x minus 3. These next ones are they're not multiplying and dividing, they're adding and subtracting. So in order to add and subtract fractions, you have to have the same denominator. And if you notice, all of these do. So in order to add, we're going to keep the denominator and collect like terms. So that's 2x squared. Ooh, that's 0. And that is minus 8. Now you ask yourself, can you reduce, which means can you factor? Well, let's see. If I can take out a 2, am I done? No, because this is the difference of two squares. Now the x plus 2's divide out. I'm left with 2 times x minus 2 over x plus 2. So adding with like denominators are easy, but you still got to check to see can you reduce, which means you still have to factor. Now these next two both have a negative sign. That has to be distributed to everything behind it. So we're going to keep the denominator of x squared minus 49. Keep the x squared. Then we have a minus 10x and a plus 21. Be careful. Now can we factor minus 7 minus 3? Then the difference of two squares. Can we reduce? And we have x minus 3 over x plus 7. Again, do I need to put those parentheses in the final answer? Not really, but you can be safer that way. On number 71, we're going to keep that same denominator, keep the first numerator just as it is, and then we're going to distribute that minus sign. Then we're going to keep the denominator just as it is, and we're going to collect like terms. So that is 2x squared. That's minus x minus 15. Can I factor and reduce that? Probably. But you know, I'm going to factor that denominator first. That looks a little bit easier because it has that 1. So how about 6 and 3? Positive 6 and minus 3. Then that has a 2, 15, 3 and 5, and I'm thinking the 3 is going to go here and the 5 is going to go here. Check it. Does that give me a negative 1 in the middle? Yes, it does. That divides out. I'm going to be lazy. And that is your final answer. So make sure you read the directions, look at the problems. Are you multiplying? Are you dividing? Are you adding? Are you subtracting? On these two problems, we are just asked to complete the table of values. So they're telling you what x can be, and they're telling you what y can be. So here we're going to let x equal to 0. So 6 times 0 minus 5y equals to 10. That's 0. Divide by negative 5. Now you're going to let y be 0. So we start over. That's 0. So we have 6x equals to 10. Dividing by 6, and make sure you reduce all fractions. Then you're going to let y equal to 2. So we have 6x minus 5 times 2 equals 10. 6x minus 12. Add 12. Divide by 6, and again reduce. Number 73, same thing. We're going to let x equal to negative 3. Negative 9 plus 9 is 0. We divide by negative 4 and we still get 0. So that tells me that's probably not a good problem. So how about let's change that 0 to a 1. Let's let y equal to 1. So 3x minus 4 times 1 plus 9 equals to 0. 3x minus 4 plus 9, that's going to be 5, subtract 5, and divide by 3. So we get negative 5/3. And then we're going to let x equal to 5. So we have 3 times 5 minus 4y plus 9 equals to 0. 15 minus 4y, those are both positive. So that's going to add to 24, subtract 24, and divide by negative 4, and we get positive 6. The next portion of the review sheet deals with lines, and here we are asked to graph the lines, but also we have to find the intercepts. Now that's really a big clue to tell you different ways you could graph those lines. And so since it asks for the intercepts, I'm going to graph it by the intercept method, which means I'm going to let 0 stand for x, and I'm going to substitute 0 in for y and solve. So if I take that equation, I have minus 0 minus 2y equals 4. Well, that's 0. Divide by negative 2, and I get negative 2. So that's one intercept. Now I'm going to let y equal to 0. So I have negative x minus 2 times 0 equals 4. So I have negative x equals to 4. That's like a negative 1, so I divide by negative 1 and I get negative 4. Now I'm going to plot those 2 points. So this is my y-intercept. This is my x-intercept. And then you should really use a straight edge, but my computer doesn't really let me, but that's pretty good. Okay, so one more time. That's your y-intercept, and that was 0, negative 2. This is your x-intercept of negative 4, 0. This is the x-axis, that's the y-axis. Again, use those clues. So here I'm going to do the same thing, substituting in zeros for my variable. So 5 times 0 minus 4y equals negative 20. Dividing by negative 4, I get positive 5. Then 5x minus 4 times 0 equals negative 20. That's 0. Divide by 5, and I get negative 4. So there's my 0.05. There's negative 4, 0. Totally coincidental, that's also negative 4, 0. It's not always that. So again, this is my y-intercept. And this is my x-intercept. Now these next two, that doesn't have an x and a y. It just has an x. So I have to know that that is a vertical line where x is 2. Oops, kind of missed it there. Hopefully you should know it's on 2. Okay, so do I have a y-intercept? Does it cross that y-axis? No, it doesn't. So I would say no y-intercept. But it crosses the x-axis at 2, 0. And that's my x-intercept. Here I only have a y, but it's not quite as easy as 76. So how about let's solve for y? So subtract 6, divide by 3. So I have to know that this is a horizontal line of y is equal to negative 2. So the question is, does it cross the x-axis? No. So it has no x-intercept, but your y-intercept right here is at 0, negative 2. Easy, but kind of hard. You've got to memorize those.